Hey everyone, so my name is Zach Vines, and what we're going to look at today is how to set up a hypothesis whenever we're dealing with two sample hypothesis tests. So I had a previous video, and I'll link that in the description and timestamp it for you, where we talk about just the standard format to how to set up a hypothesis whenever we're dealing with hypothesis testing in general. And at that point, we were just dealing with one sample hypothesis test, where we had a big population where we're taking a sample out of that population. We're running data on it, and thus for that one sample, we're going to have a particular hypothesis setup. That's just a standard format based on a one-tailed test or a two-tailed test. At this point, those terms should be fairly familiar, but if not, I very strongly recommend looking at that video before moving on to this. And again, I'll have that in the description and everything. But when we're looking at two sample hypothesis tests, there are really two main categories that these tests are going to fall under, and each of them are going to have their own particular hypothesis setups. They're going to be very similar, but it's first important to know the definitions and distinguish between them. Then after this, we'll show kind of the standard format for them, and then on a separate video, which I'll also link in the description, we'll run through a couple of examples of how you actually set up those hypotheses. So to start with, the two main categories that these two sample hypothesis tests fall into are going to be independent samples and matched paired samples. So independent samples, it might be what you automatically think of when you're going through these tests in the first place, where it's just simply two different groups that we're wanting to compare to one another. So there's an overall population, and we're going to take one sample, so one group from that population, and then another one. And each of those groups are going to be two different groups, and we're going to introduce a specific treatment on each of those groups. So for an example on that, what I gave was that we're looking at a placebo versus an actual treatment. So let's say we have one group, there's some new medicine, some new treatment that we're trying to test the effectiveness of, and we look at the placebo group, give them, a sugar pill or whatever the case may be, make them think they're getting the treatment, and then we look at the actual treatment that we gave them, and we analyze the differences between them. So there are two different groups, two separate treatments are given to them, so it's an independent samples test. And one thing I want to point out on those is that the information that you receive on those problems, they're probably going to give you the number of trials for one of those samples and then for the other samples. So you're going to see an N1 and an N2. And if it's a mean-based problem, they're probably going to give you the average of one sample and the average of another sample. So an X bar 1 and an X bar 2, or if we're dealing with a proportion-based problem, an F1 and an F2. So that kind of brings into the two sample aspect of these hypothesis tests, because we don't just have for our three-number summary N, X bar, standard deviation, so on. We actually have one for each sample. So that's one very specific characteristic of the independent samples two samples hypothesis test. So to distinguish against that, when we're dealing with the matched paired samples, that's often, it's not always a before and after, that's usually the way I like to think about it to sort of keep things straight. They often fall into what you could think of as a before or after mentality on the same group. So for these, we're not going to have an N1 and an N2. What's happening is that we've already conducted testing on an individual group that we introduced this treatment to, and we're going to see the average difference between what happened before and after. So instead of having N1, N2, X bar 1, X bar 2, we're going to have just that one N and what we call D bar, which is just the average difference between the two. So maybe at a point in time we did sort of have two separate groups of information like you would see under independent samples, but by the time you're actually working through one of these problems, it should pretty much condense all that into one overall difference to where it's almost going to look similar to just the one sample hypothesis test. But it's dealing with a difference between two samples, so it is two samples. The two examples I give of that is testing a weight after a diet. So if you have one person or several people, and we're seeing, okay, we want them to lose weight, how are we going to make them lose weight? Let's measure their weight before we introduce this diet. They go through the diet, and then let's see afterwards so we can test the effectiveness of the diet. So you can see it's one group of people that we introduce a treatment to, and then we take the difference between what happens before versus after that specific treatment. Another example would be like if there was this new golf ball, let's say, and they think it's either lighter, more aerodynamic, or in some way, shape, or form is more effective for swinging and going farther when you're playing golf. And so they have a group of golfers, and they put an old golf ball right there. They swing, they see how far it goes. They put the new golf ball there, they swing that and see how far it goes. Then you analyze the difference between what happened with them. So even though it's two different golf balls, it's the same golfers that are swinging those golf balls or swinging the clubs to hit the golf balls, and we're seeing the difference based on that. So it's one group where a new treatment is introduced, and that's what's distinctive of a matched paired sample. So I don't want this to drag on too long. I'm going to briefly show you the overall kind of standard setup for these hypotheses, and then we'll do another video to actually go over a few examples of how to practice setting them up. Okay, everyone, so these are just the standard setups that you're going to use for independent samples and matched paired samples whenever dealing with two sample hypothesis tests. So let's go ahead and just start with the independent samples and the two-tailed tests. So first of all, there are two different ways you can do it based on whether or not you have a mean-based problem or a proportion-based problem. So remember, you always hypothesize about population information. So every single variable you see throughout any of these hypothesis setups has to be the population-based variable for whatever it is we're wondering about, whether or not it's a mean or a proportion or a mean difference, etc. You have to put those variables in there. So for mu1 minus mu2, that's literally the population mean of the first sample minus the population mean of the second sample. Down here, when I say pi1 minus pi2, that is the population proportion of the first sample minus the population proportion of the second sample. One very important note is that when I say pi1 and pi2 right here, anytime that I say pi throughout all of this, the end of the story is that it needs to be the population variable. So sometimes in certain classes, I've seen the population proportion variable be p instead of pi. So just make sure that whatever class you're in, whatever the population-based variable is, that's what you put into the hypothesis. So if it's not pi, it's probably going to be p, but just make sure based on your particular class that you're putting in the right variable. So essentially, the mentality that goes into deciding whether or not it's one-tailed or two-tailed, I've covered in the previous video dealing with the one sample hypothesis test. Long story short, it's essentially that if we are talking about two directions, I'm wondering whether or not the difference between these means or these proportions is a particular number or anything other than that particular number. It's a two-tailed test. And if I'm wondering whether or not one mean might be greater than the other mean, so I'm concerned with one direction only, whether or not it's larger or smaller, is going to be a one-tailed test. So again, if you're a little bit shaky on that still, I'll link the video to where you can see kind of the overall idea of how you even decide whether or not it's one-tailed or two-tailed. But odds are, by the time you've gotten to two sample hypothesis testing, you probably have a more firm grip on that than before. So look at that if you're still uncertain about it. But for a two-tailed test, it's just mu1 minus mu2 equals x, doesn't equal x, so it's very similar to the one sample hypothesis setups. The same thing if it's a proportion, just use the proportion-based variables with pi instead of mu. If it's a one-tailed test, then you're saying mu1 minus mu2 greater than or less than equal to just x, and all these x's is just some number that we're wondering about. It will define that in the problem for you, or it's going to be the pi1 minus pi2 is greater than, less than x, so on and so forth, whether or not we're dealing with a mean or a proportion. So that's how you do it for the independent samples. So I know it's kind of a very high-level overview, but stick around for the example video next, and we'll sort of, lay out the details of how you define these. But this is just sort of the framework at play to start with. Finally, when we're dealing with a matched paired hypothesis setup, with the two-tailed test, two-tailed is always equal to, not equal to, whereas the one-tailed has a greater than, less than, or equal to in the null, and then the opposite in the alternative hypothesis. So whenever we're talking about a matched pair, because the mean difference between those two samples is called d bar, like we talked about at the beginning of the video, we're saying mu d. So the population average difference is equal to a number, not equal to a number, or it's the one-tailed less than, greater than mentality as well. So I know that's very general to start with, but I'll put the link in the description for the next video, so stick around if you want to see a couple of examples on that, and thank you for watching.